Hey class, sorry I can't be there. Today we're going to be graphing in slope-intercept form. So let's start with some warm-up questions just to remind you what you learned about slope-intercept form last week. So slope-intercept form is a equation of a line in the form of y equals mx plus b, where m represents the slope of the line or the rate of change, and b represents the y-intercept. And we can identify the slope and the y-intercept by looking at the equation. The slope is always the coefficient in front of the x, so the value in front of our x, and our y-intercept is always the constant that's being added to the end of our equation. Or it's always when x equals 0. So if we plug 0 in for x and solve for our y value, we would get our y-intercept or our b value. So looking at our first equation here, we have y equals negative x plus 5. So the negative here represents our slope, and that's an implied coefficient, so it's like we actually have a negative 1 there. So our slope would be negative 1, and then the plus 5 would be our y-intercept. If we plug 0 into that equation for x, we would solve for y, we'd get y equals 5. So that's our y-intercept. In B, 2/3 is in front of the x, so 2/3 is our slope, and then negative 1 is our y-intercept, the constant being added to the end. And then in C, we have y equals 5. Notice in C, it looks a little different than the first two. There's no x value, so this is similar to when we have 0 x's and then plus 5. So in this equation, we have no x values, so our slope is actually 0, so this would be a horizontal or like a flat line, and then our y-intercept is 5. So that's one of those special cases. So today you're going to learn how to graph knowing the slope and y-intercept, and that's kind of our goal for today. So identify the slope and y-intercept of the line, and then use the slope and y-intercept to graph the equation. So here we have our slope and y-intercept form is y equals mx plus b. So similar to the last one where we had just a 5, we're missing one of the terms. And if you look closely, we have an x term, but we don't have a b term. So you can add a plus 0 at the end because 2x plus 0 would be the same thing as 2x. That means that our y-intercept is at 0 and our slope is 2. So when you first start the equation, you're always going to start at the y-intercept. This is going to be your starting point. So just a reminder, the x-axis runs horizontally and the y-axis runs vertically. So when we graph at y equals 0, that's the origin right here. So on the y-axis where y equals 0, we're going to put our first point right there. And then to graph slope, we need to remember that slope is rise over run. We have been practicing calculating slope between 2 points, and we've been finding the rise over the run to calculate that slope. And so now we're going to graph it. My slope in this one is 2. And just like when we work with like a whole number and we times it by a fraction, remember you can always put a whole number over 1. And we're going to want to do that because 2 over 1 is the same thing as 2 because we want a rise over a run so we can graph it. So that's positive 2, positive 1. So you're going to go up, positive direction is up, and then positive 1 is to the right. So you're going to go from your point and you're going to go up 2 over 1. You're going to put your first dot right there. And then you'll do it again. Up 2 over 1. Put your next dot there. And then you can do a couple more. Up 2 over 1. And put a dot there. And you could keep going infinitely. And you could go back the other way as well and create a straight line. And you'll notice if you go down 2 over 1, you'll get another point on that line. And all of the points that I graphed here and all of the points in between, these are all solutions to this equation, y equals 2x. So if I want to name one of the solutions, I could pick any of these points along the line. So I could pick the point 0, 0, or the point 1, 2, or the point 2, 4. So let's just list a couple of those. Because lines go on forever in both directions, there are infinitely many solutions to this equation. You could continue to keep plugging in x's and getting y's. So there are infinitely many solutions. Whoops, I did not mean to open that, excuse me. All right, let's do another one. In this equation, we have y equals x minus 8, and our slope-intercept form is mx plus b. So the value in front of the x is our slope, and we have just an x, and if we have an x, we have a 1x, so our slope is positive 1 this time. And then our y-intercept is the plus negative 8 at the end, so the minus 8, so our y-intercept is negative 8. So the first thing we're going to do is we're going to graph the y-intercept. So we always start at this y-intercept point. So remember, the y-axis is the vertical axis, and you're going to go on the y-axis, and you're going to start at 0 and then go down to negative 8 and put your first dot right there. And then we have a slope of 1. That's the same thing as 1 over 1, and we want that to be our rise over our run. So that's positive 1 over positive 1. So we're going to go up and to the right again, both positive directions. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, etc. And we could do that an infinite amount of times. So I'm just going up and over, up 1 over 1, up 1 over 1. For a slope, rise of 1, run of 1. Rise 1, run 1. And then I'm going to draw my line. And because there's infinitely many solutions, I'm going to draw the line with the arrows at the end, showing that this line goes on forever in both directions. And I could continue to keep graphing points infinitely. I only have a 10 by 10 graph. But if you were to look at this graph on like a graphing calculator app or on the computer, the line would continue infinitely. Pick a couple points to name as solutions. I could use the point, let's see, this one, if I go over, that's over 7, down 1. So 7, negative 1 is a solution. You could use your y-intercept. That one was 0, negative 8. Or any of the points in between. So we have 2 and negative 6. Could do 3 and negative 5. Could do 4 and negative 4, etc. How many solutions does it have? Infinitely many. Okay, if we think about our slope-intercept form, mx plus b, in front of the x, we have a negative. So that means our slope is negative 1. And then we are missing a plus b. And we could add a plus 0 to the end, and it would not change the equation, which means our y-intercept is 0 again for this one. So we have y equals negative x. So that means if we do rise over run, we have negative 1. If anytime we have a whole number slope, we're going to put it over 1. So we have our rise over our run. This time our slope is negative. So instead of going in the positive y direction, we're going to be going in the negative y direction, but then the positive x direction. So it's negative 1 for our rise, or down 1, and then run of right 1. So positive. So we're going to start at our y-intercept, which was 0. So that means we're going to start at the origin. It's going to be our first point. And then we're going to do a negative 1 over positive 1. So that's down one to the right one. And then down one to the right one. So down one to the right one. Down to the right. Down one, right one. And you'll notice when you get enough points and you draw your line, you are drawing a negative sloping line this time. So the line is going down. It has a negative slope. Notice that +1 and -1, this direction would work as well. Positive divided by negative. So you could go up and left would be the same thing as down and to the right. If we have y equals -7, and we think about our mx plus b, you might notice that you're missing the x. It's still y equals, so it's still in slope-intercept form, but we have no x term. So this is the same equation as y equals 0x's minus 7, because 0 times anything is 0. So 0x's is 0. And so our slope is 0, and our y-intercept would be -7. So we're going to start by our y-axis here, and then graphing our y-intercept at -7. We're going to go all the way down to -7. And put our first dot right there. And then slope is 0. So you can think of it as 0 over 1. Basically, that means you go up 0 over 1, up 0 over 1, up 0 over 1. And it ends up being just a horizontal line then. It is flat. It has a slope of 0. So it looks like this. It will go on infinitely in both directions. But all of the points along here will have a y value of -7. So any of our solution points will be like -5, -7, +5, -7. 10, -7, 1, -7. All of them have a y value of -7. Okay, a couple more. If we look at y equals mx plus b, first worth mentioning f of x, that was our function notation. F of x is just the same thing as y equals. We can treat it the same way. So our slope is in front of the x value, so we got a slope of 1/3. And then we have a y-intercept of +4. So along our y-axis, I'm going to start with my first point at +4. And then my slope was 1/3. So that is a rise of 1 and a run of 3. That means I'm going +1 direction and then +3 direction. So I'm going up and then I'm going to the right. So from this point first, you always start with your y-intercept. I'm going to go a rise of 1 and then a run of 3 to make a slope of 1/3 and put my next dot right there. And then I'm going to do that again. Rise of 1, run of 3. And then rise of 1, run of 3, up 1 over 3. And so this line is less steep than the other lines I've had so far. So I'm going to draw this. And it will go on infinitely in both directions again. We'll do one more together. So this one is another special case, y equals mx plus b. And maybe you'll notice right away, instead of y equals, I have x equals. So this one is not in slope-intercept form. This is actually a special case. You might want to star this one. This is a vertical line. Y is 0 this time. And our x, it's x equals instead of y equals. So x equals some number, like x equals a, is a vertical line. vertical lines have slope that is undefined because it goes straight up and down. And it would be at where x equals 6. So this time we're looking at the x-axis. It's giving me an x-intercept. If I go over to where x equals 6 and I put my dot here, this equation says x equals 6 everywhere. So that's like a vertical line straight up and down where x equals 6 everywhere, forever, in both directions. So that's why our slope is undefined. It's straight up and down. It's like going up 5 and over 0. And we can't divide by 0. So our slope is undefined. And then it runs parallel to the y-axis. So here's the y-axis, here's my line. They're both vertical, which means they will never intersect. And if they never intersect, then this line does not have a y-intercept because the y-intercept is where it crosses the y-axis, which means there's none for the y-intercept. Now, any of the points along this line here are solutions to this x equals 6. So any of those points, you could do 6, 3, 6, 5, 6, 10, 6, negative 2, 6, negative 8, etc. You could do 6, 0, so 6, 0, 6, 1, 6, negative 5. Any of those points. Again, there's infinitely many solutions in the end. Okay, so just to recap, you have positive slope. Your line should end up looking like this. So if your m is positive, make sure that your line is rising from left to right. It is increasing. As x values get bigger, so are your y values. So this is m equals a positive number. If your m value is negative, your line should be decreasing from left to right. As your x's are getting bigger, your y values are getting smaller. So double check anytime you have an m that is a negative number, you are graphing a negative sloping line. And then you have the two special cases where m is equal to 0, should be a horizontal line. And then you have the one that we just did where you have a vertical line, and that is specifically when you have your x equals some number, and then it will be straight up and down. Okay, we'll review this again tomorrow. Thanks for watching.